Alright, we need everybody quiet. Shh. Quiet down. What are we gonna do? We have nobody to. We have nothing. What is this company gonna do? We're dropping. We're in debt. Like, we have nothing to do. Come on, guys. Any ideas? Oh, I have an idea. I made some plans. So this is my convenient Ferris wheel. For some reason today I brought it to work, but so this is our Ferris wheel. It's halfway underground. Our diameter is 300 feet, and this is what we're gonna do with our Ferris wheel. We're gonna call it the Underloops, and this is my project. Alright, well, you might be wondering how I just teleported. You also might be wondering how I got shorter. We're not gonna talk about that though, because we have a business plan right here, and we need to get this done. So now, this is our Ferris wheel. It's gonna be halfway underground. Why? Because that makes it so much cooler. Now, we are gonna have a person sit right here on pi, or normally you would say 180 degrees. So, why? Why do we have to do this? Because normally, every time you build a Ferris wheel, of course you have to put somebody on the Ferris wheel and make sure it works on graphs, because who doesn't do that these days? So now, our person is gonna be sitting on pi / 180 degrees, and it takes 2 full minutes to go all the way around our Ferris wheel. Yeah. That's a big Ferris wheel. Oh, and did I mention our diameter is 300 feet and our radius 150 feet? Alright, now if you take our graph, we're going to have sine. And the reason why we're going to have sine is because if you put this into the formula, so we have I conveniently brought this paper. So now, okay, so this is the formula. So we have y equals a, and of course it's a sine graph, sine of b x minus h plus d. Alright, so I'm going to read it off to you because it's kind of hard to see. So now we have y equals 150 sine with pi over 30 and then x in parentheses. So basically what this means is it's just the formula of how we're going to make our graph. Now, this is a very basic and crappy graph, but I'm going to explain it in the best ways I can. Now, this is our midline, right? So this right here, this line, is exactly where the middle of our Ferris wheel will be, or just ground level. So now, it's hard to see backwards. So now, here's our origin. So this is 0, 0, right where these two lines meet. So it's going to go up 150 feet, and then you're going to go down 150 feet. Then you're going to go underground 150 feet, and then you're going to go back up, which is where you'll get off. And all that's going to take 2 minutes. So basically, these are the 5 points. Where you start, so which is 0, 0. Then the next point, which is, it would be 1 over and then up 150 feet. So it would be 1/4 of 2 minutes, which is just 30 seconds. So within 30 seconds, you'd be 150 feet up. Then in another 30 seconds, you'll be back at pretty much ground level. But then in the next 30 seconds, you'll be 150 feet underground. And then in the next 30 seconds, you'll be back at the end, or your starting point, you could say. Oh my gosh, how could I forget? The most important thing about this stunning graph. Now look at, if you don't know what a sine graph is, it's pretty much, think of a circle. Now, as the circle goes around, you're kind of graphing that onto, of course, a plane. So as the time goes on, which is where you are on the Ferris wheel, or whatever you're on that circle, it's going. So think about it. Now, if I'm starting right at 150, which is right on the midline, which is right where a sine graph would start on the origin, I'm going up 150 feet because the Ferris wheel goes counterclockwise. No, clockwise. So when a Ferris wheel goes clockwise, it's going up 150 feet first. Then I'm going back down because I'm getting all the way up to the maximum height. So I'm starting to go back down, and then I'm getting back towards the ground level. So now that I'm back at the ground level, I'm going underground because our Ferris wheel goes underground. And now I'm underground, 150 feet, which is the lowest point of our Ferris wheel. So then you start to go back up. Now what these mean is this is an amplitude. 150 feet is our amplitude. That's why it also goes negative 150 feet. Now your amplitude can change from your radius of your circle, or your diameter. Now the length of the time of our Ferris wheel is called the period. So the period is 2 minutes. Now, the way we would find this is because however long it takes you to go around your Ferris wheel, that's your period. So if it takes you 10 minutes to go around your Ferris wheel, you have a very slow Ferris wheel, plus your period's 10 minutes. So that would make you have a lot longer graph unless you just put it onto a small piece of paper and put 10 minutes like I did. But that's basically how you can read this graph. Now, earlier I said you're going to get on here and get off here. I was lying. You're actually going to get on and get off here. I'm changing up plans as I'm going. Initially we wanted to get off here, but it made the sine graph a little wonky because you would have to get off at 1 minute. And we don't want that because if you're going to pay for the Ferris wheel, you want to go all the way around. So you're going to get on and get off here. We're going to have not really a staircase, but we're going to have something to get to the carts. So we'll have something to get to the carts and get off the carts. And that's pretty much it. I taught you what the midline was. I taught you where all our points were, the 5 important points. I taught you our formula, and I hope the CEO likes our graph because we really want you to fund us so we can make this Ferris wheel happen.
Our Ferris wheel was cool because our amplitude was the radius and the x-axis was level to the ground.
My boy Dominic, he didn't have any facial recording, so I'm just going to have to put some math memes up. So here you guys go.
How does the drawing of the Ferris wheel compare to our actual Ferris wheel? So, the drawing shows not only the dimensions of it in radius and the height of the actual Ferris wheel and distance from the center to a cart, but it also shows how the Ferris wheel is actually in the ground. The Ferris wheel, its total height is 300, and only 100 feet of it is underground. And that is demonstrated in the drawing, the model, you can say a blueprint, that was made by our group.